To understand our world, we must look through the lens of why.
Welcome to This Explainer. Today, we're going to explore a genuinely groundbreaking discovery by a Yale-led team. They've essentially captured the elusive birth of a supermassive black hole. We are talking about an object so extraordinary, it's completely rewriting our understanding of how the absolute most monstrous entities in the universe actually come into existence. Okay, let's dive right into this by posing what is arguably one of the greatest unsolved mysteries in astrophysics. So we know that supermassive black holes exist at the centers of most galaxies, right? But here's the problem. When we look back at the very early universe, just hundreds of millions of years after the Big Bang, we already see incredibly massive black holes. How in the world did they manage to get so big so quickly? It's honestly like walking into a kindergarten classroom and finding a fully grown adult sitting at a tiny desk. There simply shouldn't have been enough time in the young universe for them to grow to that massive size through normal means. To crack this mystery, astronomers needed a time machine. So they turned to the NASA Cosmos Webb survey data, which was captured by the absolutely phenomenal James Webb Space Telescope. Because light takes time to travel across the universe, peering deep into space with this incredibly powerful telescope is literally looking back in time. We're looking deep into our cosmic history, in some cases, over 13 billion years ago. It allows us to observe galaxies exactly as they were when the universe was just in its infancy. All right, part one, the suspects, light versus heavy seeds. Now, scientists haven't been completely in the dark on this mystery. We essentially have two main suspects, or theories, to explain the origins of these ancient giants. Let's break this science down simply. The crucial point here is the massive difference between these two theories. First up, we have the light seeds theory. This suggests black holes started small, born from the collapsed cores of the very first stars. But to become supermassive, these light seeds would need to continuously gorge on matter and merge with other black holes over billions of years. On the flip side, we have the competing heavy seeds theory. This proposes that large clouds of gas skipped the star phase entirely. Instead of fragmenting to form stars, the entire cloud underwent a runaway gravitational collapse directly into a massive black hole. So, if this heavy seed theory is correct, these black holes don't start small, not at all. They skip the evolutionary line entirely. It's basically like going straight from high school to a PhD in cosmic mass, being born at a whopping 10,000 to 1 million times the mass of our sun, right out of the gate. This incredible head start perfectly explains how they could become supermassive so early in the universe's history. But, for a long time, this was just a theory. Why was it just a theory? Well, because for a direct collapse to actually happen, a very specific and incredibly rare set of extreme environmental conditions has to exist. Let's walk through these ingredients slowly. Normally, gas clouds cool down and fragment into smaller clumps that form normal stars. To stop this from happening, you need pristine, metal-free gas. You also need a massive blast of specific ultraviolet radiation, known as Lyman-Werner photons. These essentially act like a cosmic sterilizer, destroying the molecular hydrogen which usually acts as a coolant. If you can keep the gas hot, it won't fragment into stars. Instead, the whole massive cloud collapses under its own gravity until it reaches an extreme density. This triggers what physicists call a relativistic instability, which basically just means gravity wins so completely that the matter violently caves in on itself, instantly birthing a black hole. Yale astrophysicist Priyanvada Natarajan has actually championed this heavy seed theory for a long time, and her theoretical work gained massive traction recently with a combined Chandra X-ray and JWST discovery. They found an actively growing supermassive black hole in a galaxy called UHZ1. Now, this galaxy existed just 470 million years after the Big Bang, and the black hole inside it was incredibly massive compared to its host galaxy stars. It was a massive victory for the direct collapse theory. Moving right along to Section 2, the smoking gun, enter the infinity galaxy. But listen, as exciting as UHC1 was, the true smoking gun for this direct collapse theory arrived in 2025. And this is where things get truly mind-blowing. Astronomer Peter Van Dockum and his team at Yale, while they were scouring the Cosmos Webb data, discovered an unprecedented anomaly at a redshift of 1.14. That means we're seeing it as it was over 8 billion years ago. What they found was a textbook head-on collision of two massive disk galaxies. These galaxies had distinct ringed nuclei, and because of the collision, their structures were violently warped. Against the dark backdrop of space, the glowing wreckage perfectly mirrored the mathematical symbol for infinity, which is how it earned the brilliant nickname the Infinity Galaxy. And this brilliantly illustrates the violent timeline of what happened here. Let's replay the tape and break down this sequence. About 50 million years before the light we see left the galaxy, these two huge disk systems approached each other and just crashed. Now, when galaxies collide, the stars mostly pass right by one another. But the massive clouds of gas between them slam together at absolutely incredible speeds. In the Infinity Galaxy, this gas was shocked and compressed so intensely at the exact point of contact that it formed a dense knot. And right there, in the chaotic center of the collision zone, that compressed gas collapsed directly and birthed the newborn supermassive black hole.
Of course, in science, you have to do your due diligence and rule out every other possibility, right? The team acted as rigorous cosmic detectives here. They used a suite of world-class observatories, including the Hubble Space Telescope, the Very Large Array, and the Chandra X-ray Observatory, alongside the JWST, to cross-examine this object. By measuring their radial velocities with JWST, they proved the gas and the black hole were physically locked together in space. It wasn't just some optical illusion. They confirmed it is not a background galaxy, and they completely ruled out the possibility that this was just a wandering, runaway black hole passing through from somewhere else. No, it was born exactly where it sits.
You can literally hear the sheer awe in Van Dokkum's realization here. Remember, galaxies usually have supermassive black holes in their centers. But this newborn black hole wasn't in either of the two original merging galaxies' nuclei. It was sitting right in the middle of the wreckage, forming directly from the compressed gas. They were catching a baby supermassive black hole in the literal act of being born, via direct collapse right in the collision zone. Okay, let's bring it all together. Section 3, the verdict, rewriting black hole history. So what does this all mean for us? Well, this single observation forces us to totally expand our view of how the universe operates. What you should take away from this explainer is a fundamental shift in astrophysics. For a long time, direct collapse was thought to only be possible at the very dawn of time, relying on the pristine, metal-free gas of the early universe. But the Infinity Galaxy shows us that nature is far more creative than we thought. It doesn't just rely on dying stars or ancient, untouched gas clouds. It uses the extreme, violent gas densities generated during massive galactic collisions to forge supermassive black holes directly from gas, seemingly across the entire lifespan of the universe. Which leaves us with this final, mind-bending thought to ponder. If these cataclysmic heavy seed births are happening right now in the violent collision zones of merging galaxies, rather than just at the edge of time, how many more of these newborn monsters are out there hiding in the cosmic dark, just waiting for us to point our telescopes in the right direction? It's a wild universe out there.
Why settle for shallow facts? Join the intellectual rebellion. Subscribe to Y Lens now.